Welcome to this session. As promised in the previous session, we are going to discuss a numerical integration formula based on Newton forward interpolation formula. So remember from the previous session, our main problem is to evaluate this definite integral from a to b of the function f of x dx. So we call this one question 1. So I'll say let the interval this interval a b be divided into n equal subintervals such that we have a to be equals to x naught, and then x1, x2, x3, up to xn, and let this value xn be equals to b with xn given by x naught plus nh, and then h is given by distance b minus a divided by the number of subintervals. So remember, this is to say that we have this closed interval a to b, and then so this a, you divide it into equal subintervals. So we have, this is x naught, x1, x2, x3, x4, etc. up to the last one is xn. So this xn minus 1, xn minus 2, in that order. And so the spacing of this is uniform h, 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 h. So we have n subintervals from a to b. Then with this division, then the integrand or the integral 1 becomes I equals to the integral. Now a is the same as x naught, so you write x naught. B the same as xn, so x sub n, f of x dx. Let's call this one relationship 2. So then now, or we can write this one as, now starting from x naught to xn, we have n subintervals. So you can say, similarly say that integral we're integrating from 0 to n f of x dx. There's another way we can interpret that integral 1. From the 0 strip to the nth strip or the n xn coordinate. Now, using Newton forward difference formula or interpolation formula, so Newton forward interpolation formula, remember, is given by F naught plus P forward F naught plus P into P minus 1 over 2 factorial, second forward F naught plus P into P minus 1, P minus 2 over 3 factorial, third forward F naught, where X is given by X naught plus PH. This is the Newton forward difference formula or interpolation formula. So what we are going to do, we are going to rewrite this integral 2, where this f of x will be replaced by this expression for Newton forward interpolation formula. Hence, 2 becomes I is the integral from x naught to xn of, now instead of f of x, we write f naught plus p forward f naught, p into p minus 1 over 2 factorial, second forward plus p into p minus 1, p minus 2 divided by 3 factorial, third forward of f naught plus other several terms of the same pattern, and then dx. So what I've just done is to replace f of x by this Newton forward difference formula. But since, so let's call this one 3. Since x is given by x naught plus ph, this implies that dx, remember x naught is a constant, the same as h dp. So that becomes I equal to the integral. Now remember, x naught to xn is the same as 0 to n. And so we'll have where this dx we replace by h dp. So h being a constant can be factored outside the integration sign. So I'll have h into f naught plus p forward f naught. Now opening this one, I'll have p squared minus 1 minus p, and then to factorial the same as 2. So this like over 2, this over 2. Second forward f naught plus, when you expand this one, you get p power 3 over 6, 3 factorial is 6, minus 3p squared over 6 plus 2p over 6. And then third forward of f naught plus other terms. And then this now is dp because dx was replaced by hdp and h has been factored out because a constant. So call this one 4. Now integrating for term by term, we have I is equals to h into, now remember f naught is a constant, so integral of f naught with respect to p just be p f naught plus forward f naught is just also a constant, so integral of p dp is the same as p squared over 2, and then forward f naught plus integrating this one with respect to p, we'll have p power 3 divided by 6 minus this one will be p squared divided by 4, and then you multiply by this constant second forward of f naught plus this will give you p power 4 and then over 24 minus this one, when you divide this is a half, so the p power 3. Now here we have 1 then 2, so 6, and then this will be 1 over 3, so p squared, and then over 6, and then multiply by third forward of f naught plus other several terms. And then remember, we are integrating from 0 to n. So here is 0 to n. Actually, to be specific, say p equals to 0 from p equals to 0 to p equals to n. So that was the variable for integration. So p equals to 0 to p equals to n. So which means all the lower limits will be 0 because at least every term here has a p. So we'll have h into, so when you replace the p by n, you'll have n f naught plus n squared over 2 forward f naught plus, now this term here, common is 12. So 6 into 12, 2, so 2p cubed minus 4, this is the 3p squared. So I'll have 2n cubed minus 3n squared divided by 12, and then second forward of f naught plus, now here LCM is 24. So I'll have p power 3, p power 4 minus 6 into 24 is 4, 4p squared, p cubed plus 4p squared. So when I replace by n, I'll have n power 4 minus 4n cubed plus 4n squared divided by 24. Third forward f naught plus other several terms. Now you see every term here has an n, so I can factor out n. So I have I equals to nh into f naught plus n over 2 forward f naught plus, now because I've factored out one n here, so this will be n power 2, and here we have n. So I can add this one as n into 2n minus 3 divided by 12, second forward of f naught, plus, now this one, when I factor out n, so the first one remains with n power 3, and then minus 4n power 2 plus 4n plus other terms. Now, this part here, I can factor out n, so I have n into n squared minus 4n, and then plus 4. And this is a quadratic expression, which is the same as n minus 2 times n minus 2. If you multiply this one, then you get this term here. So, i.e., the integral I is nh into f naught plus n over 2 forward f naught plus n into 2n minus 3 divided by 12 second forward of f naught plus, now here I factor out n, and then this is n minus 2 squared divided by 24, and then this is the third forward of f naught plus other terms. Then you close the bracket. So therefore, this is the formula that we get when we integrate formula 1 or integral 1 by Newton forward interpolation formula. Let's call this one star, because we'll make reference to it to derive other formulas. So from star, we can, from the general formula star, we can find different integration formulas depending by putting n equals to 1, 2, or 3, etc. And then this formula star is also called a star is also called the Newton's quotes closed quadrature formula. So in the next session, we will derive a trapezoidal rule based on this formula star when we put n for 1. So please watch the next session for derivation of trapezoidal rule. Thank you.